Good morning. So this video presents a demo on text classification for PubMed articles, and the complete notebook was made by Team Cyber Predators. Team members are GIRISH Pandey, that's me, roll number 110710426.
And I am VEMU LAKSHMI. My roll number is 1107 11141.
So initially Ananya will explain how we loaded the data and formed the single data frame. Later on I will explain the text engineering process. So over to Ananya.
Thank you, Girish. For this project, we chose a data set from PubMed articles. We chose around 10,000 articles of vaccine, COVID 19, cancer, genome, and virus. For each class type, we follow the following steps. Firstly, we inputted the data set here as a text file. For each article in the class type, we separated PubMed ID, title, abstract, and created a list. We then found out the articles that has no abstract and we printed the PubMed ID number. In the next step, we imported pandas to create a data frame with columns as PubMed ID, title, abstract, and class type. We then added a new column as content that has all the details of title and abstract. Then we re-index the columns as PubMed ID, content, and class type. The same procedure was followed for COVID 19, cancer, genome, and virus articles. In the final step, we concatenated all the data frames. And here we can see that 10,000 articles are there for all the 10,000 articles are present for COVID 19, vaccine, cancer, genome, and virus. We stored all these articles as a CSV file. I would request Girish to take off from text engineering.
Thank you, Ananya. So initially we added one more column as label, which is nothing but a mapping of each class label to a number. So as you can see, vaccine was mapped to number 3. Then for complete text engineering we need certain modules. So initially we imported NLTK, that's natural language processing toolkit module. Apart from it, we use word tokenize for tokenization, stop words for removal of stop words, wordnet lematizer for lematizing, snowball stemmer, and port stemmer for stemming. So we defined a function named NLTK process in which we encapsulated each of these following processes: tokenization, stemming, lemmatization, like removal of stop words and removing punctuations too. Next, to be sure, we just tested this complete function against a random sentence. Then once we were sure, we then introduced another column named clean text and applied this function on the content column of our data frame. After this, we divided a complete data frame into two parts: training part and testing part. Training part is used to train the classifiers, which we will discuss later on, with the tuples which we had, and testing part is used for validating them. So the proportion of training is testing is 69 is to 33. That means 69% training part and 33% testing part. Each of the training and testing part contains two things. One is the corpus, that's the content, and second is the labels name, like each sentence is mapped against which class label. Then we calculated the total training and testing count for each labels. Now later on we use this training and testing data to showcase in our classifier. So first we use naive based classifier In that we imported multinomial naive Bayes. For this, after fitting the classifier with the training data and training labels and the testing it against the testing corpus and label, we got an accuracy of 96%. Apart from it, we even use CV's accuracy. CV here means a cross validation with respect to 5 folds. So that was certainly 96, 95, 96, 96, etc. And mean CV was calculated, that was around 96%. Thus, apart from this, we calculated other parameters such as accuracy, precision, recall and F1 score and stored them in separated variables. The same procedure of calculation of parameters and fitting the training model and testing them was followed for each classifier, like logistic regressions, the linear support vector machine, SGD classifier, random forest classifier and gradient boosting classifier. After this, we use TF-IDF approach, that is term frequency inverse document frequency. Till now we used only term frequency, whatever classifier which the data upon the data which they use were based on term frequency. Now we are compiling on IDF also. So here we use TF-IDF vectorizer and just use this function name fit transform on our training corpus to get the TF-IDF corpus. Next, we use this new TF-IDF training features and testing features against each classifier. The same process was carried out. The only difference is we just replaced the previous TF features with TF-IDF features. And again the same parameters like accuracy for each classifier was carried on and calculated. Later, we just summarized all the CF score test scores of all the classifier into a single data frame. As you can see, highest CV score was achieved by linear support vector machine. Even the highest test score was achieved by logistic regression. CF score was also highest of logistic regression, or little bit difference. Test score was also second highest. Overall, we can say that these two, that is logistic regression and linear support vector machine, are the two classifiers which produce a better output in terms of CV score, that is cross validation and test score. Apart from it, if we talk about the accuracy and precision, so the highest accuracy was achieved in logistic regression, and it was achieved in linear support vector machine, and again the precision was highest in linear support vector machine SGD. I think same was true for all. Like apparently we can say this value was almost top positions for all the measures: accuracy, precision, recall, F1 score. Next, we calculated n-grams. As you know, n-grams is nothing but number of words. So here n can be any integer value 1, 2, 3. So 1 gram, 2 gram, 3 gram, that means unigram, bigram, trigram represents the set of list of individual single words, 2 words and 3 words. So initially we just use a program for calculating unigrams, then we did the same for bigrams, and further we calculated every gram, that is based on the length of the sentence, the number of n-grams can be generated out of it. And for this complete process we consider a random sentence. So that's what our project was. Hope you will like it. Thank you.